Okay, I'm going to go through the sample final. So this is like the one we had very beginning, velocity and acceleration. T is the time, and the velocities are in meters per second, so the time must be in second. And it says use the trapezoidal rule. Let's see, the trapezoidal rule says basically says find the average of the left and right hand sums on the first 10 seconds. So we're going to have to do it, we can do 5 of them here. So we're going to do the left 5, which will be, see, the intervals are 2 seconds every one of them, so we're going to take 2 times the left sides. So of this interval, that's the 2.5 plus the 2.3 is the left side of this, and the left side of this one is 2.1 plus the left side of this one is 1.7, and the left side of this one is 0.9. 1, 2, 3, 4, 5. And I'm going to get 2.5, 4.8, 6.9, 7.6, 8.6, 8.6, 9.5 times 2, which is 1819, and that would be, this is finding the area, so it's meters per second times second, which turns out to be meters. And the right 5 would be 2 times, not this one, everything else, but adding the 0.3. So I'm removing 2.5, and adding the 0.3. So if I take 9.5 and remove 2.5, I get 7, and add 3, I get 7.3, which is 14.6 meters. I did the math in my head, so I hope I didn't make any mistakes. But the trapezoidal 5 for this would then be 19 plus 14.6 divided by 2. So that would be 33.6 divided by 2, which is 16.8. Should be between them, and it is. So hopefully I did the math correctly there. I'm sure I'll hear about it if I didn't. Find the average value of the function on this interval. So remember, the average value is the formula 1 over b minus a, the width of the interval times the area of the 1 over the width times the area, from a to b of f of x dx. So it's going to be 1 over pi over 2 minus 0, integral from 0 to pi over 2 of the sine of 2x dx. And if you make the u sub and figure that out, or you just can think that taking the derivative would produce a 2, taking the antiderivative we have to divide by 2, so we're going to get, this is 1 over pi over 2, which is 2 over pi, inverting and multiplying that. And the antiderivative of the sine is going to be negative cosine of 2x, but we're going to have to divide by 2 because of the chain rule piece in there. And we're going to evaluate that from 0 to pi over 2, and take it, and we've got this here. So this becomes 2 over pi cosine of, see, this would be 2 times pi over 2, which is just pi. Cosine of pi is negative 1 over 2. Cosine, so negative of negative is plus 1 over 2. Minus a minus, which would be plus, and then we put in 0. Cosine of 0 is 1. So that'd be 1/2. So 1/2 plus 1/2 is 1 times this, so it's 2 over pi. Okay? All right. This one, if it's an even function, same on the right as it is on the left, from minus, let's see, from 0 to 2, the area is 3. So in here we have an area of 3. And then from minus 2, which this has to be the same amount over here, if it's even. It would be negative if it was odd, but it's even, so we've got 6 so far. And if we go from minus 2 to 5, and we end up with 7 total, and we've already got 6, this has to be 1, which means back here is 1. So if we go from 2 to 5, that would be 1. If we go from minus 2 to 2, we're going to get 6. If we go from minus 5 to 5, none of those are backwards, we're going to get 4 plus 4, 8. Okay? Next one, the indefinite integral. To do the antiderivative of x to the 4th, we add 1 to the power, so it becomes x to the 5th, but then we divide by the new power. The antiderivative of x to the minus 2, we'd add 1, we get x to the minus 1 divided by negative 1 plus c. Now, probably we should write this as 1/5 x to the 5th, or x to the 5th over 5. That's fine either way. Plus, put this in the denominator, and it becomes actually a minus 1 over x. Simplifying that a little bit. That one wasn't bad at all. Next one. Use the fundamental theorem of calculus to evaluate this. Well, these are added or subtracted, so we can split those up, and so we get the integral from 1 to 3 of 3 times 1 over x dx, plus nothing to bring out of that, so it's integral from 1 to 3 of x squared dx minus 2 integral of dx from 1 to 3, 1 dx. This becomes 3 ln of x, but we're going to put in 3. 3 is positive, so I didn't need to put the absolute value. And then I'm going to put in 1 minus ln of 1, positive, so I don't need anything. Ln of 1 is 0. Plus, this becomes 1/3 x cubed. We put in 3, and we get 1/3 of 27, or 9, minus, put in 1, and we get 1/3. And then here, that goes to x, and so we put in 3, and we get minus 2 times 3 minus 1. And no plus c, because this is a definite integral. So we get 3 ln 3 plus 9 minus a third minus 6 plus 1. So 9 plus 1 is 10, minus 6 is 4. 4 minus a third is plus 3 2/3. Hopefully I didn't make a mistake. This one I want you to use calculus on it, not just do the decimal approximation. And I want you to also do it on here. Now this is subtraction, so we can split these two up. And the derivative of tangent is secant squared, so the antiderivative of this would be tangent x. This is x to the 5 halves, the fifth to the power 5, and then square root. So if I do the antiderivative, I'm going to add 2 halves, 1, and so I'm going to divide by, see, that would be 7 halves. So it'll be plus 2/7 x to the 7 halves plus c. Okay, this one shows the speeds of 2 participants in the race. And this is in feet per minute, and this is minutes. And it says graph the distance between them if they start at the same place. So I'm going to put this, I'll put a line, I'll put it here. And these squares are, let's see, they're 2, 4, 6, 8, 10. So these are 2 minutes apart. And they're 2 feet. So these things takes, in 2 minutes, it goes, this would be 2 times 2, 4 feet in 2 minutes. So this is a change in 4. So the distance between these two runners, I could graph adding up the squares under this for how far the dotted one goes. The dotted is steady snail, steadily increasing in speed. So I could add up the squares underneath, 4, 4, 4, and that would give their distance. But I didn't want that. I want the difference in their distances, which would be the area between the curves. So if this one's 4, this is a little less than 4, and this is a little less than 4, so that would be 8 minus, okay, if these are 4, there's 1, 2, 3, 4, so this looks like about 1, and this is a little less than 1, so 2 of them would be 8 minus 1.5, so 6.5, my estimate. The area between these, so if I'm dividing it by 4 again, this looks like almost 2. So this is a little over 2, and this would be quite a bit over 2. So I got 2, 4, maybe 5. And then here, the area between will be, that's a little less than 2, and this is about 2, so maybe 2, 4, 3.5, and this might be about 1. This is the area between, so this person, that was the dashed is Harry the Slug. Harry the Slug would be going ahead of Steady Snail. And in the first 2 minutes, it would be 6, and then 5, and then 3. So that's going to be 9, 10, 15. So I'm going to go 5, 10, 15. They're going to get 15 apart. The distance between them is going to be 6.5. So there's 6.5 would be about there. And it's linear, so it would be increasing, but it's getting less, so it's going to be a concave down. The next time it's going to go be 5 more. So 6.5, but 5 is 11.5. That's somewhere there. And then the next one, 3.5 more than 11.5 is about 11.5 plus 3 is 14, 15. No. Yeah, 15. And then one more. So that would be like that. And then the distance, one overtakes the other, and the distance is going to get closer together. This might be 1, so I'll come down maybe 1 or a half, something like this. And then this might be a couple, so it's going to come down by 2. And this looks like it might be about 3, so it'll come down another 3. And then this looks like it might be almost 4. Almost 4, maybe 3, so I'm going to come down to maybe here. And this one is 4, maybe 5, so come down 5, which would be about here. And then this one is 4, 5, almost 6, so that would come down to here. And this would be 4, 6, 7-ish. So it'd be down here. And this is almost 8. So it'd be down here somewhere. So who's ahead at the end? Well, it's going to be Steady Snail. Steady Snail was behind at the beginning. This is saying that the slug is ahead. Harry the Slug, the dash line, he's ahead at the beginning. He takes off fast, slows down, and then holds his speed, but Steady Snail constantly picks up speed. So the slug is ahead, but then falls behind in the end. So Steady Snail wins. Oops. And that's not off the screen there. And it looks like it's by about 10, 11, 12 feet. Just by the graph. Okay. So who's ahead depends on who's going faster, and the area between them is the graph of the distance. Okay. All right. Use substitution to integrate this. Okay. U equals 1 minus 5x squared du equals minus 10x dx. dx equals du over minus 10x. So this becomes the antiderivative of x over square root of u, and dx is du over minus 10x. The x's cancel. The minus 10 in the denominator comes out as minus 1/10. The antiderivative, this is 1 over square root of u, that's u to the negative 1/2 du, which is, I add 1 and divide by, what do I get? If I add 1, I get a half. Divide by half is the same as multiply by 2, so I get minus 1/10 times 2u to the 1/2 changing back to x's. So this is minus 1/5 square root of 1 minus 5x squared plus c. Integration by parts. I'm going to let u be x. Its derivative would be 1 dx. I'm going to let e to the 2x dx be v prime. Antiderivative will be 1/2 e to the 2x. So this becomes uv minus 1/2 x e to the 2x minus the antiderivative of the opposite direction. That's the one we did this way, which would be 1/2 e to the 2x dx. And we know how to do the antiderivative of that. We just did it. And so we get minus 1/2 x e to the 2x minus 1/2 times the antiderivative of this is 1/2 e to the 2x plus c. And if you had trouble doing that antiderivative, do a u sub for the 2x and you should be able to see how to get that. So simplifying this a little bit, we get minus 1 over x over 2 minus 1/2, and both of those are times e to the 2x. That's one way you could simplify. Not necessary, but you could. Do this one by partial fractions. Well, x minus 1 factors to 2 linear factors. If it's a linear factor, you just need an a over it and a b over it. And this is supposed to equal 3 over x squared minus 1. To get this common denominator, I'd have to multiply this one by x plus 1. And this one I'd have to multiply by x minus 1. And so to make this identically equal, there's no x's here, so a plus b, ax's plus bx's, so a plus b has to be 0. That means a and b are equal and opposite. And the constant, 3, would have to equal 3a minus 3b. Oh, excuse me, a minus b. Well, that's easy enough to solve. Just add these two equations. They get 3 equals 2a. b's cancel. So I divide by 3, and a equals 3/2. b has to be negative 3/2. So this problem this integral turns into two separate integrals. The a would come out of this one, so we'd have 3/2 the antiderivative of 1 over x minus 1 dx plus the b is negative 3/2 antiderivative of 1 over x plus 1. And if you do u sub, this becomes 1 over u du, and so it's ln x minus 1 minus 3/2 ln x plus 1 to do this one, where it goes to infinity, 0 is not a problem. E to the 0 is just 1, but infinity is. So we write the limit as b approaches infinity of the antiderivative to 0 to b of e to the negative x dx. Not doing the limit yet. The antiderivative of e to the negative x is negative e to the negative x. Evaluated from 0 to b, which becomes, not doing the limit yet, negative e to the negative b minus a minus, which is plus, and e to the 0 is 1. And if it's e to the negative b, that's something that gets closer and closer to 0. And if it goes to infinity, this goes to 0, and we get 1. Trig sub, we've got a subtraction. So the triangle has to have the positive part of this on the hypotenuse. So that would be 1. The square root of 1 is 1. And on one of the legs, I have to put in the 9x. You notice the 9 is squared in this, so I'm going to do a 9x. I'm going to put it here, and then the square root would go here, and it would be 1 minus 9x quantity squared. So now what is x? Well, 9x over 1 is opposite over hypotenuse, would be the sine of theta is 9x over 1, so I'd have to divide by 9. Then the derivative, we need to find dx, so the derivative sign is cosine, so it's 1/9 cosine theta d theta. Don't forget to write the d theta on that. And then the square root would be, let's see, that would be adjacent over hypotenuse, which is, minus 9x quantity squared, would over 1 is the cosine of theta. So this becomes the antiderivative. The dx is 1/9 cosine theta d theta over cosine theta. The cosines cancel, and I get the antiderivative 1/9 the antiderivative of 1 d theta, and that would be just theta. And so to solve for theta, I'd multiply by 9 and then do the arc sine. So it's going to be arc sine of 9x plus c. 13. 0 pi, no problem, so I should be able to do this one. It's x times sine, so I'm going to probably do it by parts. May not be very easy to do. Let's see. It doesn't say to do it by parts. It doesn't say to use trig sub and show all that. So I'm just going to pull out the calculator and do it that way. So I'm going to go on. I'm going to go to y equal. I'm going to type in x sine of x squared. Second, calculate the area between 0 and pi divided by 2, and I get 0.8668. Trying to think if I could do this one by parts. Let's take a quick look. I don't think that's going to work very well because of that square on the sign. So if I put x here under u, then this would be dx, and if I put sine squared x dx, the antiderivative of sine squared, according to our table, is this big mess. It's x over 2 minus 1/2 sine x cosine x, using rule number 1. So this would be uv, so that's going to be x squared over 2 minus x over 2 sine of x cosine x minus the antiderivative of x over 2, these two multiplied, so that would be x over 2, just a sec, dx, and then minus a minus, which would be plus the integral of 1/2 sine x cosine x dx, and a u sub for sine or cosine will be able to do this. So this would become x over 2 minus x squared minus x over 2 sine x cosine x minus, integrating that would become x squared over 4, and this would be plus 1/2, and we'll do u sub for, it doesn't matter either one. I'll do u equals sine x, du would be cosine x dx, and then I would do divide by cosine x, and that would or the cosine x dx is du, and this would be u, so it becomes u squared over 2, but u was sine x, so it's sine x squared, all evaluated from 0 to pi over 2, so I'd put pi over 2 in for all the x's, and then I'd put 0 in for all the x's and subtract those two, and I should get that answer. So it does work by parts. All right, got a little bit more here to do. Let's see if I can get this done, and then I'll find out what the gentleman wanted. Consider the area bounded by y equals the square root of x. That looks like this. Y equal 2. 1 is, this is 1, 1, so 2 would be up here, and you'd hit at 4, because the square root of 4 is 2. And x equal 0. X equals 0 is this, so this is that area that's bounded by that. Spin it around the x-axis, so it would cause a thing down here going this way. Find the volume of the solid. I can do it with rings or with discs. Let's do it with disc first. Actually be washers. So it'd be dx thick, and it's pi large radius squared, which should be constantly 2, minus the small radius, which should be y of this, but it's going to be dx, so I'm going to use the square root of x squared, evaluated from 0 to 4. Okay, so we'll have pi, antiderivative of 4 is 4x, antiderivative, see, square root of x squared is just x, so the antiderivative of this is going to be minus x squared over 2, evaluated from 0 to 4, and I'm going to get 16 minus 8, which is 8 pi. If I put in the 4, I get that, and then if I put in 0, I'm going to get nothing. So 8 pi. Now let's do it with rings. So I'm going to go this way. So it's 2 pi integral. It's going to be a dy, and y is going to go from 0 to 2. And it's going to be, the radius is going to be up y high. So it's going to be y, and it's dy, so that's great. And this direction is x, but x is y squared. Solving for x in that, square both sides. So this is y to the third. Antiderivative of that would be y to the fourth over 4, and that would reduce this to a 2, and we got to evaluate it from 0 to 2. So 2 to the fourth is 16, divided by 2 is 8 pi, and putting in 0, I get 0, so I get 8 pi. Both of them. Calculate the work done by a climber pulling a rope up that is 2 pounds per foot, and it's 150 feet, and down there is the backpack that's 40 pounds. So those are already weight. This is a weight density, linear density, and this is a weight, so it would be 40 plus 2 times however much rope is out here, and that's going to change, so I'm going to call it x, 2x, and we want to pull it up a little bit at a time, so this would be pounds. This is already pounds. This is the 2 pounds per foot times the number of feet. This becomes pounds, which is a force, times the distance. We're going to keep going little distances until we get from 0 to 150. And so it's going to be 40x plus x squared, evaluated from 0 to 150. And we're going to get whatever 40 times 150 minus 150 squared. Put in zeros and you get 0. Whatever that works out to be will be in, this is foot pounds. Determine the work pumping out the top half of a spherical tank. So I'm going to take a slice, to a location 10 feet above the tank. So I got to go up 10 feet. So, and the radius of this tank is 8 feet. So that's also 8 feet. Don't forget that. So a slice will be pi r squared times, I'm going to put the axis here and I'm just going to call this y. So it'll be dy. That's the volume of a slice times the density of water, which is 62.4 pounds per cubic foot, and this is the cubic foot, so this makes the force pounds, times the distance we have to lift it. Well, we're going to take this slice up 10 plus this distance. Now that's not y, this is y. That whole length is 8, and this is y, so this is 8 minus y, so we got 10 plus 8 minus y, which is 18 minus y. And we're going to add this up as y goes from 0 to 8. And r, that was the r. This is y, that's x. And so 8 squared minus y squared is that side. Square root. But we want to square it, so it's going to be pi comes out, 62.4 comes out, integral 0 to 8 of 8 squared minus y, 64 minus y squared, for that, r squared. And that stays, that goes out, times 18 minus y dy. So I would FOIL this. I'd take 64 times 18, 64 minus 64y minus 18y squared plus y cubed. Integrate the pieces, or type this into the calculator, and we would get an answer. Let's see what we get for an answer. So I got pi, clear, 62.4 pi times parentheses 64 minus x squared, close parenthesis, open parenthesis, 18 minus x, close parenthesis, and we're going 0 to 8, so zoom 6 will get all the x's. The y's are going to be way off the screen, but that's okay. Second, calculate 7 from 0 to 8. And it's going to be 1003701, and this is going to be work in the English system, foot pounds. Okay. A thin rod has a linear density by this, so many grams per centimeter. Find the total mass. That would be the integral. Let's see, how long is the rod? 1 meter long. This is in centimeters. A meter is 100 centimeters. So 0 to 100 of 1 over x squared plus 2. I think I meant that to be x squared plus 1. All right, well, I did 2, so I'm going to have to do that dx. And so I'm just integrating the density dx for the length of the rod in centimeters, and I'm going to get grams for my answer. Okay, so this is so many grams per centimeter times centimeters, and a meter is 100 centimeters. So we get clear 1 divided by the quantity x squared plus 2, close parenthesis. Second, and I got to go up to 100, so I got to do window up to 100, graph, and it's kind of small, I can't see it there. Second, calculate 7 from 0 to 100, and it comes up with 1.1007. 1.1007 grams. That's the density. And then to determine the center of mass, I have to take the same thing, which would be x over times x, the twist on it, so x times this is x over x squared plus 2 from 0 to 100, dx divided by the mass, which we already got, 1.1007, and we get, so all I have to do is go back here and put an x there and go second, calculate 7 from 0 to 100, and that comes out to be 4.258 over 1.1007, and that would give me the center of mass. Okay, so it's the density and the density with an extra x in it for the twist, the lever arm for each of those little pieces. That's how you find center of mass. And that comes out to be, second quit, it should be somewhere between 1 and 100 meters. So comes out to be 4 centimeters. About 4 centimeters, a little less than 4 centimeters. 4.258 divided by 1.1007 comes out to be center mass to be 3.868 centimeters. And that's because the mass of this was really big at the beginning and then it got really thin. Do you remember the graph on how that looked? Y equals 1 graph on, hold that, stop that, and make the window in the Y much smaller. Go from -1 to 1. You can see it's a lot of density at the beginning and then almost nothing after that. So that's why it's so close to this end to balance it.